Our experts for this webinar today are Heather Himmelberger, Project Director at the Southwest Environmental Finance Center, and Ross War, founder of War Infrastructure Management. Today's webinar format is different from traditional webinars. At any point that you would like to ask a question, please type the message to us in the questions section box on your control panel. Our moderator for today's webinar, Dawn Null, will read the question out loud and allow our experts to respond. Heather and Ross, please take it away.
Thank you very much, and thank you all for being here today. Let me just put this on. Okay, and Savannah, are you seeing my screen?
Yes, I can see it perfectly.
Great. Again, thank you all for being here today, and just as a reminder, we'd like to focus this as much as possible on questions that you have about asset management in your system. So feel free to type in questions as we go along in the chat box, and we'll get to as many as we can. But just to kick things off today, I wanted to have Ross focus a little bit on some things he's been contemplating about the Flint, Michigan crisis. And we know kind of the human side of Flint, Michigan, but there's an asset management side to that whole situation. So we're going to start off today just by talking about level of service, cost, and risk as it relates to a situation like Flint and how an asset management program can help a utility that has to face those kinds of decisions.
Well, thank you, Heather. And this diagram that you're looking at here came from some work we were doing in New Zealand about 3 years ago, and we're still working our way through this. And so we call it, there's these three axes, if you like, of level of service, cost, and risk. And the thing that struck me when looking at Flint, of course, is that risk was hidden. Normally we think about changing the dollars and all the levels of service. So if you, for argument's sake, put a new treatment process in, you'd have to spend some dollars to do that. That improves your level of service because your water quality might be higher, that sort of thing, or a different maintenance program or some pipe replacement or things like that. And so when I started thinking about Flint, because I think it's going to affect a lot of utilities, not just here in the US, I think there might be across the Western world some impacts from that, is what they started doing is they had this problem that they needed to save some money, they were perceived. So they changed what they were doing in levels of service to save themselves some money. And that risk from an asset management point of view that was hidden, the problems that we now know about with Flint, started increasing. But nobody could see it because the risk was hidden. And it's about, I guess, the thinking we're doing in New Zealand and sort of a bit wider than that about this is how do we communicate that hidden risk, and how do we actually quantify it to the point that, in the case of Flint, an administrator could make some good decisions around that. So what happened there, this threshold line, which I'm calling the safety and trust threshold, is that risk crossed the safety and trust threshold, and all of a sudden it's visible to everybody. And so all of the health problems that are known. And of course the cost is going to be for Flint multiples more than the cost of not having done what they're doing. Could be hundreds of millions of dollars before that problem's finished to be sorted out. So and that can happen in any supply. I mean, they've had a particularly bad problem there. So the levels of service are down below the safety and trust threshold. The dollars appear to be down, but in fact they aren't. The risk becomes apparent, the problem's there, lots of dollars, lots of inquiries and things like that. So in Western society, if you're in a dictatorship, what would happen in that sort of circumstances? They'd probably arrest people or shoot them or whatever they do. In a Western society, what happens is this final diagram here. So we spend a whole lot of money to fix the problem. That pushes the service levels back up again. The risk comes down below the safety threshold, so we've now got safety, but we've lost trust and we never get it back again for a very, very long time. And so that impact across our industries then is legislation and regulations, the costs of alternative action, there'll be litigation or class action, the overall societal cost as well, and of course we end up with a whole heap of inspections and investigations mandated out of that, and that's simply these sort of things come from not understanding what's happening with that hidden risk. And a couple of examples that have dropped out recently with that was obviously in a transportation, the Mississippi Bridge failure back in 2007. So it killed and injured, lots of disruption, lots of dollars to fix. And as a result of that, right across the US transportation now, there's multiple bridge inspections to try and manage the problem. But again, at the end of the day, it was how do you model that factor of safety? And if we go back, Heather and I were talking about 60s and 70s, early 80s, we had a lot of processes and procedures in our industry and utilities that would provide multiple factors of safety. And as pressures come on to save money and or change things, some of those have come out, and I don't know that we know quite where we are in terms of our factors of safety on our risk. The final one we'll talk about before we go back to Dawn to see if there's any questions was Walkerton in Canada in 2000. Small town, had a water supply safety incident that was due to, at the end of the day, corrupt and criminal practice, but people died and people were ill. And over in New Zealand, so miles away from Canada, our public health officials looked at that problem and said, hey, the same thing could happen in New Zealand. And over a decade, we've had $1 billion of new capital expenditure, planning requirements, lots and lots of small water supply treatment and source protection upgrades. Our equivalent of the federal government hasn't funded all of that, so it's been a cost on very small communities, increased long-term operations and maintenance cost, and that came from an incident in Canada. And so, as I said with Flint, I think you'll find that once the inquiries are all finished, there'll be mandated practice that will impact right across the US, probably up into Canada, also Australia, New Zealand, the UK, just to make sure that sort of thing never happens again. And so it imposes a societal cost, and again, just not knowing about your risk. So.
And just a couple of follow-up points is I just saw a news story the other day about Flint and this whole idea of losing the trust. And so EPA came out recently, or maybe it was a state agency, I'm not sure which, and said the water's safe to drink as long as you have these filters in place. But when they interviewed the residents up there, none of them that they interviewed were willing to drink the water because the trust, as Ross was mentioning, is gone. They don't trust when the agencies say it's okay. The trust has been lost, and they're not willing to accept that. So the trust is gone. So again, it's going to even lead to more expenditures because the only thing that they indicated would allow the trust to come back is if they got a brand new water utility. So they're talking about, well, if you replace all of our pipes, which, you know, I think I heard somewhere around the 350 million to 400 million range, but I'm not sure if that's exactly correct or not. But you're talking about replacing, you know, all the service lines and all the house piping before people's trust is going to come back. So it is something that once lost is going to be
really
exceedingly hard to come back. And the other point I wanted to make is, you know, risk, as Ross mentioned at the beginning, it was a hidden risk, and they weren't really understanding the risks. You know, at least we hope they weren't really understanding the risk clearly at the beginning. And when we did our survey with the American Water Works Association, we surveyed utilities across the country and asked them about their asset management practice. The area that by far was the lowest across the board for all utilities was the understanding of risk and understanding, you know, what the risk of individual assets was. Now, this is kind of a little bit different type of risk, but it just shows in general, you know, the understanding of risks at our utilities is a practice that we really need to improve so that we can make better decisions on an individual asset basis or an individual system, overall system basis, so that we can avoid the types of problems that were shown here.
Yeah, so and I see we're getting questions coming in here, so we should go to Dawn.
Okay, one of the first questions is I've just started the asset management process, looking at my inventory for one asset category, and I'm considering the condition assessment. I've been advised to look at how long the asset's been in place and use its life expectancy to determine condition. Are there other things I should be considering?
Ross, do you want to start?
Yeah, that's a really good place to start. Make sure you've got a reasonable inventory of accuracy that's appropriate, I think, so we would like to use for the assets you're managing. One of the things I do often, just when you're starting with something like that, is I go, well, is that asset in, just split its life up. Is it in the first third, second third, or last third of its life? And so if it's in the last third of it, you're going, well, maybe I need to know a little bit more than just an age approximation of condition. The other thing to look at there is to say, well, is it just a pipe that's feeding half a dozen houses, or is it the main pipe in from my tank and my well field? So what happens if I lose that pipe? And that might cause you to look at it a little bit differently from a condition point of view. But age approximations where you start, and working out the ones that are in the last third of their life is a good rule of thumb, just to then guide any further work that you might want to do.
And just a couple of other things to think about as you're looking at condition is, what do you know about its maintenance history? You know, is it one you've been taking good care of over the years, or is it one that you've kind of been ignoring? And if you've been ignoring it, the chance that the condition is a little worse is probably better. If you've been doing a lot of maintenance and really taking good care of it, the condition might be a little bit better. Thinking about its repair history, you know, how many times is it broken over the past, 5 years, 10 years, etc. Is it a lot of breaks? Anything you know from maybe your long-term operators who are more familiar with particular pieces of equipment, asking them about, well, what's your experience with pipe or wells or tanks or whatever it might be, asking them questions about condition can be another place that you can look for condition information. So kind of just using what you know is a great place to start. You don't need to go into huge lengths to hire expensive technologies and whatnot to look at it as a starting place. I think, if you just using what you know about those assets, how they've been maintained, how they've performed, and, maybe even thinking about the materials of construction. If it's pipe, for example, how does cast iron pipe in your system compare to ductile iron pipe or PVC pipe? So looking at those kinds of things. So just using what you can know. If you can actually observe it, visual observations is another good thing. We can't observe, underground assets, but looking at, things that you can visualize is other things you can look at.
And particularly with the metal pipes, because you don't tend to go cutting holes in them unless you need to, or any pipe. But sometimes you'll be putting in a hydrant or a valve or something like that in a pipe that's been in the ground for maybe 100 years or 150 years, and that just gives you the opportunity while you're doing that, say to the guys, hey, can you give me the bit that you've cut out? Let's have a look at what the internal wall's looking like, and have we got some build-up of material or anything like that, or pitting or whatever it is that's coming in your area. And so it's taking those opportunities, I think, just natural opportunities as they come along without spending money to go specifically sampling for condition, just to have a look at what's happening and form an opinion about the overall, or the condition from those samples.
And I think the only time we really see water utilities going great lengths to get condition assessment is, if the risk is extremely high. So if you have a pipeline that's like the main transmission into your system and it's under a railroad track and it's not encased in a pipe or something, and the consequence of that rupturing would be so tremendous, you could hire somebody who could come in and
or under an interstate or something like that.
Under interstate, whatever. You could hire somebody to come in and actually do a visual inspection on the inside of the pipe, as well as collecting wall thickness data and that sort of thing. But it's not necessary unless you have a very high-risk situation to really go to those extremes, especially if you're a small utility. A larger utility might do that, but a smaller utility, that's probably more information than you need. So you can start it simple and then look at the factors that seem to make the most difference for you, and then really focus in on those factors later on to keep it simpler and not get yourself overwhelmed. Okay, Dawn, do we have another question?
Thomas sent in a very specific question, and I'm going to kind of generalize it a little bit. So Thomas, I hope that you can accept me modifying your question a little. But the question is about the cost per year of an asset. So he is giving an example of, a simple example of a pump that costs $10,000 that should last 10 years. So if you divide that out over the course of the 10 years, and then by month, he figures that to be $83 a month if you set aside the depreciation for the asset. So the reason for the question is that someone else was looking at interest only and figured a 6%, and he's asking if he's missed something, or if when you're looking at the cost per year of an asset, what should you take into consideration?
And I'm not sure if he's talking about the $10,000 just being the purchase price, or that's the purchase price and the operation and maintenance costs. So my first thought is we need to be thinking about both, you know, the initial cost to purchase the piece of equipment and then the annual cost to operate and maintain that equipment. So it sounds a little bit like we're just talking about the purchase price. And then I'm wondering if it's a matter of trying to put the money aside to be able to purchase the new piece of equipment later, or just the financial transaction of doing a depreciations, because they're two different things kind of. So sometimes we use the concept of depreciation when we're looking at rates and rate structures and that kind of thing, but we're not actually setting the money aside. And sometimes we're trying to set the money aside for later to be able to purchase that equipment. So kind of two different things.
Clarify that you would like it to be for replacement costs.
Okay, so for replacement costs. So in those cases, we're looking at, I mean, I think he's on the right track to say we need to put money aside in, like, say, a reserve account is a logical place to put that money. And looking at, okay, if it's going to cost me $10,000, you know, 10 years from now, I'm going to need $1,000 a year. He is correct in saying that there will be some inflation in that price. It's unlikely to be exactly $10,000 today and $10,000 10 years from now. However, it's a little bit unclear exactly how much increase there will be in the cost because technologies change.
You know, I think that's a really good point, because even with just a very simple pump, 10 years later, you've got a disposal cost in there as well of your existing pump, but you might find that your mounts have changed, and certainly your control technologies will change in that period, and so it's just, you need to think about disposing and you know, what do I need to do to actually get the old pump out and put the new one in, but also that's quite often it's just not a like-for-like replacement. So your thinking's changed, or you got some more demand, or whatever it is, and that's not just replacement. Then you got some additional capital, but they're not as simple as you initially think, those sorts of things. So if you are putting money aside, it's just also thinking about the end-of-life handover as well, in terms of the cost equation there, and whether you'd then take that opportunity to update your electrical and control systems.
And I think, you know, you were talking about a 6% increase that somebody suggested, and I think you could choose what interest rate you think seems to be the most appropriate.
But if you're good at that, change your job and work in Wall Street, because I mean nobody's getting that right at the moment. So
yeah, I was going to say the same thing. Like, you know, just putting in the concept that you don't think 10,000 is going to be the exact cost 10 years from now. And if you want to be a little maybe on the safe side, you put a higher interest rate. If you want to be a little less conservative, you could put a lower interest rate. But you're trying to get the bulk of the money set aside. So really that's kind of, I think, your goal is to just get the bulk of the money that you would need set aside. And, you know, your approximate, what was it, $83 a month or something, would approximate getting the bulk of the money. You may need a little bit of extra, and if that's going to be a problem to get 10 years down the road, well then put a little bit more money aside so that you kind of give yourself a cushion. If you don't think it'd be a problem to get another, say, $1,000 at the time of purchase, then, you know, just putting aside the purchase price would probably work. So it's kind of up to you what interest rate. I don't think there's any magic to say it should be 2% or 5%
Well,
or
6%
8%.
would be quite high at the moment. It depends
Yeah,
how you're...
6% is a little high, I think, but
Depends
it's
how
hard to
you're
say what
funding.
it
I
is.
mean, if you're funding bond funding, you could just go look at the muni bond average and use that sort of number, or if you're funding by land taxes or direct charges, you could look at something that's similar. In New Zealand, now each authority or each water authority has got to have basically a treasury policy that says that's what they're doing. So it's easy for the engineers because you just look at the treasury policy and say, oh yes, we're using a rate of X, Y, Z, and that's what it is. But for us, even, you know, like you go back a decade ago, it was 8% was the figure. It's not that anymore. It's well low. I think we might be using 4 or 5% now.
And if you don't have a reserve account, I would highly recommend that you get one, a repair replacement reserve, that you can put your money aside. And, you know, that's typically where we would say, like, your short term. You could have a short term and a long term if you want, or they can all be in the same. It doesn't really matter however you want to structure that. But some place where you can set that money aside, and that you have a plan that the money in there is to go for, you know, this pump and this tank and this well and this pipe, or, you know, whatever the set of stuff is, so that you have the plan, that somebody doesn't just see this money and think, oh, we can spend this on something else. You want to lock it away.
That happens more often than you'd like to
Yeah,
say.
you want to lock it away so that it is not sitting in a budget that looks like, oh, wow, we've got this extra $10,000 we can spend on, you know, who knows what. You know, let's go to a conference or something. You want to make sure you lock it away in some kind of reserve account. So if you haven't done that, I would highly recommend, you know, that type of situation so that you can have it put aside for a specific purpose.
So Thomas wants to kind of clarify that this budget that was prepared, they're planning on setting aside 6% of the $83.
Oh.
And he feels like that's a mistake. So, and I'm misinterpreted that. I apologize. So just to clarify, that would be a mistake. They would not in 10 years be able to purchase
Yes.
a new pump.
They might be able to get one that's been built in somewhere that doesn't build very good pumps and has a very funny name, and it, yeah, might do the job for a year, but otherwise...
Yeah, I mean, I think it's sort of, you know, sometimes when we look at replacements, you're just pushing the problem off to the future.
You're kicking the can down the road.
And so if you only want to put 6% away over 10 years, you're not going to have anywhere near the purchase price at the end of the 10-year period. So all you've done is say, well, I'm going to have maybe, you know, a third of the cost or a fourth of the cost, whatever it is, at the end of the 10-year period. And now I'm going to come up with the other, you know, 3/4 or, you know, 75%, whatever you have remaining. You've got to come up with that in 10 years. And how is the situation going to be better in 10 years' time than it is today? So if there isn't some reason to believe suddenly your income is going to go way up in 10 years, all you've done is kick the problem down the road, and somebody else will have to come up with a big pile of cash.
10 years is relatively short, so you can just do a time cost of money calculation and then work it back and check that against your 6%. So, and you just, the key things with them is just an assumed what they call a discount rate, but it's basically an interest rate that you're using, which is your treasury policy. It's a good discussion to have, though, isn't it, as to what you actually need to fund in 10 years, and consistent investment rather than leaving investment, or consistent putting money aside is actually a pretty good way to go, just to make sure that the renewal funding isn't a major impost on the community at that time. And pumps don't tend to be, in a big scheme of things, hugely expensive. It's when you get into pipe renewals that can just be huge in terms of the dollars, and the community will just go, we can't afford it. And then you get into questions of how you're going to actually fund that at that time. It's not as cheap as greenfields generally if you're doing replacements. So.
All right, a new question from James that's water loss and asset management related. So the question is about the water losses that are on the customer side. So if the agency doesn't have access to the private home to inspect and fix the leaks, then how can the agency, one, inspect the individual plumbing fixtures in the private homes, two, replace or repair the private leaking fixtures, three, finance the repairs or replacements, and four, enforce the program?
That's a really difficult issue. We do a lot of water loss training and working with utilities on doing water losses, and the inside the home kind of issues are super, super difficult because you get into all kinds of issues of liabilities and private property and who pays for the fixtures, as you mentioned, like suppose it's a leaking toilet. Do you pay for a new toilet put in? So usually most utilities try to go more on an incentive route or a rebate route, where maybe you'll come up with a program that if you have a leak in the house and you show that you have replaced the toilet or replaced the sink through either pictures or receipts or however you want to do it, that you can get a rebate off the cost of your last month's water bill. So that, you know, maybe you've leaked, I don't know, 3,000 gallons through your toilet, and so we're going to rebate you back the 3,000 gallons if you've shown that you put in a new toilet, or rebates to install, you know, low flow fixtures, shower heads, faucets, that sort of thing. It is really, really difficult to run a program inside somebody's house. The one thing, though, I will say from a non-revenue perspective is that you want to make sure that you have very accurate water meters. Because if people are leaking a lot, you want to at least have them pay for the water that they're leaking, because at the very least they should have the revenue, you know, the water utility should have the revenue from that, which is another price signal to people that, you know, if you want to bring that bill down, you can reduce your usage by fixing your leaks. So it's another way to kind of incentivize people to do that part.
Yeah, and if you're on volumetric charging, of course, you can look at a step charging regime where you cover the average in your normal charge, and if somebody's got a big leak and they're massively above average, they actually step up onto a higher rate. So that's the negative reinforcement. If the water's too cheap, there's nothing you can do to make people to change, can you? So. And
if it's a huge problem in your utility, like if there are tons of people for whom it supplies, it is actually one reason that the electronic read meters can be used, because you can start to track the background leakage in each person's home if you have those readings, the nighttime readings, because they'll give you some idea of, okay, this background amount at night is probably the leakage in the home, and you can provide that information back to the customers and indicate to them, you know, it is costing you this much on your bill, or you're actually leaking 2,000 gallons. So it is expensive to put those systems in place, those automatic meter reading systems. It is an expensive undertaking, so you don't take it lightly, but it is something, if you really need a way to address inside the home, it is another tool that you can consider. And, you know, our utility, the one that I'm on, has these automatic meter readings, and they will send notices to customers that they believe have leaks, and they will, you know, provide it, and they do incentives to have people repair things. So looking at incentives, looking at changing your rate structure to negatively impact customers who have the leaks, looking at automatic meter reading would be better ways to go than to try to figure out how to get your folks inside.
And that's going to be state and county or city ordinance specific as to whether you've got rights to do that even. And I think as Heather says, it just gets quite problematic. If you go and fit something up in somebody's house and then that fails, all the liability and things like that. So, Dawn.
Okay, and a question about some research. Have you performed research related to automated condition-based monitoring? For example, vibration analysis and shock pulse method for bearing verification. This would be related primarily to pumping and or mechanical equipment. This will help perform predictive maintenance rather than reactive maintenance. If so, do you have a comparison of the brands or models?
The short answer is no. We haven't done that specific research, but the longer answer is that I've certainly talked to several utilities who have done what I would term special studies to investigate practices, and I'll give you one example. It's not exactly what you're talking about, but it's on the same line. So this particular utility was looking at, well, there's actually several utilities that kind of did this, looking at their lubrication schedules. And, you know, one utility's case, they were lubricating twice a year. Others were lubricating once a year. A couple were lubricating every quarter, you know, changing the lubrication. Well, there are ways you can get your lubricant analyzed, and there are companies that will do that. And you can send off your lubricant and get it analyzed for, you know, how is it performing, is it lasting, etc. And they were able to do these studies to show that the rate of lubrication in every case was more frequent than it needed to be. So through the study of that particular information for their own exact utility, they could change the lubrication schedule, which can be a significant amount of money because it takes time to perform the maintenance, and it also costs money to get the new lubricant, dispose of the old lubricant, etc. So they were able to figure out by doing that special study that the right amount of lubrication was different than what they were doing, and they could change those schedules. So anytime you have a chance to use some technology that will give you better information of how to react, what time frames, that sort of thing, I think you can look for potentials to save money. Now, I don't know if New Zealand is doing more work in this area, Russ.
I think we have gone down that same track on occasion, but it depends on what you want to know to do all that sort of analysis, and I think it sits within a wider risk management question. So certainly with mechanical electrical plant, you can get right into the whole reliability centered maintenance analysis, and so it's just whether your monitoring and your automated monitoring adds value within your wider risk management and maintenance processes. The good news is that it's all getting, with micro sensors and things like that, it's all getting cheaper and cheaper to do continuous monitoring. I think we're going to see more of it. There you go.
So I would suggest that if you have a chance to try out some of the technologies for, say, vibration analysis, there's some temperature analyses, there's all kinds of things, and I do not have any recommendations on one company over another, but if you have a chance to try it, perform your own special study to see, if I get this information, what does that tell me about my pump? How could I change my maintenance regime knowing this? And then look at what you did before, look at what you do now, and see if it actually saved you the amount of money it cost you to do the analysis. So the bottom line is you want to save it.
Part of that wider condition analysis question, and it still comes back to what question you're trying to answer. And so it's just like any asset management of any, you got your inventory and then you start collecting condition and performance information, but you need to know the question you're before you go collecting screeds and screeds of data, because otherwise you'll just get buried in data and you won't have the ability. So if it fits into, I've got a real problem and I need to answer this question, by all means. Otherwise, think about other ways to deal with the issue. Dawn.
All right, level of service question. How involved should I have my customers be in determining my level of service, and how do I go about involving them?
Now, I can tell you, I'll give an answer and then I'll let Ross intervene because New Zealand does a lot of getting information from customers. In the U.S., we do not do a lot of that, but there are utilities that will go out and do different kinds of customer information gathering efforts. So some of them will do focus groups and they'll invite customers in to talk. Some of them do surveys, that sort of thing. But personally, I believe you want to find a way to get that customer conversation going and figure out what customers want, because they're a big part of the picture of what you're going to provide, and they're going to have to pay for it. So if they're not involved in that conversation at all, it's going to be a lot harder to convince them to pay for things and to have them understand that connection between level of service and cost. We don't have in the U.S. a very good connection between level of service, cost something. Nobody realizes what they're paying for when they pay their water bill is the service. It's not the water. And the more we can get that hammered into people's heads that what you're paying for is service. You want more service, you pay more. You want less service, you pay a little less, but they're two very tightly tied together concepts that you've got to pay for the service you get. But New Zealand does a lot better in getting the customer feedback, so maybe you can talk a little bit about what you're doing over there.
So I've just been doing some work for a client very recently. They were wanting to review their service levels. It was water and wastewater and stormwater utility. And so we had a big look at all the service levels across comparable authorities in New Zealand and also some international practice. And what the list that's on the screen on the slide here at the moment is basically how we group our service levels in New Zealand. So you've got the public health and safety ones, so that's the quality of your water, the management of environmental impacts, so the discharge of contaminants and or with wastewater, the discharge of wastewater, you'll have permits or impacts there. There's a group of service levels around response to system and network issues, so how do you respond to breaks or blockages in a wastewater system, how fast, what sort of measures do you have for time on site, time for restoration, those sorts of ones. There's a whole group of service levels around how satisfied the customer is with the service that you're providing, and then the financial performance ones are basically bang for the buck. How much does it cost? Do I get good service for that? Now, the thing is that the first two of those are usually almost always set by either permits or regulation or legislation, or over here EPA requirements, Safe Water Act and things like that. So you can consult on them, but that isn't going to change the outcome at all, because you've really got, particularly in water and wastewater, you've got minimum standards that are required, and that's going to set your base level of service. So the stuff that you end up consulting on particularly is normally around the response and satisfaction ones, or we do in New Zealand. The other thing that happens, and I think it is something that gets overlooked, is project-specific service level consultation. So I'm putting in a new treatment plant, or I'm putting in a new wastewater discharge or something like that, and it's a big project, and it's going to cost tens or hundreds of millions of dollars. And so in New Zealand, as part of our permitting system over there, we have to consult for that. And so sometimes that sort of community discussion about what's required and what would be the best solution for the community and stuff like that actually does a lot of your consultation, but it's around a specific water treatment or wastewater treatment discharge type permitting discussion. But I think the main thing, and particularly in utilities, is that a lot of it is quite regulated, so you do actually have minimum service levels.
And one last comment I want to make is the consulting process with the community can be a little overwhelming. So if you need to start at first with outlining some levels of service that you want to track just within the utility, that's a good place to start, and then go out and consult and adjust the target levels or add service levels, but don't avoid doing the service level part just because you haven't gotten the consultation done or you're not comfortable with that. just setting those service levels initially around the things that really matter to you, and at least starting that process and tracking your progress toward meeting those is a good place to start. And then from there, as you get more comfortable with the concept of level of service, you want to build in a process to get communication back from your customers and see, what do they think about either an individual project or your overall utility. But don't wait while you're trying to design a really good process to get information. Go ahead and start with some levels of service, especially those first two, public health and safety and environmental impacts. And then at least start with what you think the customer service or financial performance should be, and then adjust them as you get more input from your customers. But don't let it be a reason to not start level of service.
Yeah. The other thing we found, we've been doing service levels for about 20 years now in New Zealand, and the other thing that we have found is that when you do, for engineers particularly, consultation like this is not your natural field of expertise. So you often need some help, or some people who have got skills in that area to help translate engineering speak into public, people, what the community will understand. When you do a process, a consultation process, and over time a community consensus builds around the action, the money follows, because once your whole community agrees this is what we want and we're all happy with it, or a good majority of your community, it locks everything in. It's very, very powerful, because the community said, yes, we want this water supply or this wastewater, we want these processes, we want it at this standard, and we're happy to pay for it, or we're prepared to pay for it at least. They might not ever be happy, but it just tends to take a lot of that stuff that swirls around off the table, because you've built the consensus. It's not a quick process, so that can take years. So.
Okay, Dawn, do we have another question?
There are some states that are starting to offer asset management planning grants, and for small systems in particular, are there areas that you would recommend that they hire an engineer or some rates group or someone to help them with developing their asset management plan?
This is an area where I think you need to be really cautious. My advice is always the plan has to be driven by the community, by the system itself. So you don't want to hire somebody with the notion that I can take this burden away and give it to somebody else and they'll come up with a great plan and all will be well, because it won't work that way. It will just be a book that sits on a shelf and you won't implement it. So it has to be you as the system thinking through what you want to do, looking at the expertise you have on staff, the information you already have, and then looking where are the gaps. So maybe you want to develop a map, for example, and you've decided that you want to get a GPS location of all of your assets and you want to create a map, and maybe it's GIS of some kind, or maybe it's not even quite that sophisticated. But you may decide that, hey, we don't really have the equipment to do GPS, we don't have the equipment to do the map, so we're going to have somebody work with our operator, go out in the field, collect the GPS locations, make the map. Or you might say, well, we're going to put the information into an Excel spreadsheet or an Access database, and we want somebody to set up that Excel spreadsheet and give us a little bit of training on how to use it, or an Access database and how to use it. So looking for the gaps in where you're going to struggle with your own staff while allowing you and your staff to drive the process is the best way to do it. So looking where you need some additional expertise, maybe another good example of where some help might be beneficial is replacement costs. It's often hard for a small utility to know replacement costs of everything, pumps, tanks, pipes, whatever. So hiring somebody who can fill in that data, and say, well, we think a mile of pipe in your system would cost, whatever, $600,000. So they could help you with those replacement costs, because that's something that would be more difficult for your staff to know. Or maybe they can help you think through useful life estimates of how long, you know, this kind of thing will usually last. So using the consultant to fill a gap or plug a hole you have is a better way to go than to contract out the whole plan and hope that that's going to make change.
Yeah. I think I had a small laugh to myself there, because in New Zealand we have mandatory requirement to do these, and by far and away the best way to do asset planning is to do your own thinking. Get some help around structure from the EFC network or from Heather. Get some help around, you know, step 1 to 15 or whatever it is that you're looking at. But if you outsource your thinking, then somebody else will do your thinking. But in New Zealand, every single cycle of plans, we end up doing some. My business ends up doing some because people can't organise themselves to get them done on time. So there's that catch-22. But my first advice would be get help where you need it, like Heather was saying, but make sure you ask your own questions and do your own thinking, because that's where the learning takes place. And that's where you get the insights and can change things. And your own team will know, and yourself will know your own system more intimately than anybody else.
So it's sort of one of these buyer beware. Be careful.
We'll try that first.
Yeah.
So, and if you get bogged down, then go get some more help. Because
so just, you know, try to be a wise consumer. So certainly
smart
there's
client, we say.
Exactly. So certainly stay involved. You know, be very intimately connected and make sure that what you're getting, you know, created is going to fit the way you think, the way you want the outcomes to be, the culture of your organization, etc. Because it doesn't work well if somebody comes up with something and it's completely against the culture of your organization. It's not going to go well. You know, it's like putting the square peg in the round hole kind of thing, and you want the round peg that fits you. So get the help you need, but look for the gaps and don't just plan on outsourcing the whole thing, because it may appear to be easy, but in the end it won't help you. And the whole point of asset management is not to create a plan. It's to change the behavior and get benefits from that behavior change, and you'll miss out on the good parts by just getting a plan that won't be implemented. So just make sure you stay involved and, you know, get the benefits out of it. Don, do we have another question?
Well, while we're waiting for Dawn, we've had the situation in New Zealand where consultants have written the whole plan, not my team, but some other ones, and they've not been as ethical as they needed to be in that, and loaded a whole lot of projects in for themselves as well. And so I'm sure that never happens in the US, but
No, never.
but if it's something to watch out for as well, as you know, when you're doing your own asset plan, you can just keep a fairly tight rein on any temptation for that sort of behaviour. So.
And the other thing to look out for is asset management is about a thought process. And the thought process goes through the current state of the assets, you know, what do you have, where is it, those kinds of basic questions. Then the level of service, which is what you want it to do. Then criticality, where you're looking at which assets are critical to your sustained performance, and, you know, which ones will have the probabilities of failure and the consequence of failure. And then you'll go to life cycle costing, which gets into how you're going to operate, maintain, repair, and replace your assets. And then finally you'll move on to funding, how you're going to fund this. So also beware that an asset management program that doesn't involve all those 5 elements is not an asset management program. It's a piece of one. So you can do a piece of one if you would like to, but be aware that you will get less benefit out of the program if you don't do the whole thing. So just another caution that as you're going to, you know, maybe contract out for some of this, if somebody comes back with just an asset inventory as their whole activity, that's fine, you're getting an asset inventory, but you're not getting asset management. So just kind of keep aware that if there's not all 5 of those components, you're not getting an asset management program or a full asset management plan, you're just getting a component. And, you know, while a component can help you, it won't give you all the benefits of truly thinking in an asset management way. So again, just be careful about the two differences there, you know, the asset management pieces versus an asset management program and the full asset management thinking that goes on. Dawn, do we have you back?
Yes, I'm back. I apologize.
Do we have any
Sorry, it looks like that's all the questions that have come in.
Okay.
Well,
Do you have some final thoughts for us, Ross, regarding asset management?
well, it
And,
was just when you were talking about, oh, we've lost the screen now as well, the slides. I was just thinking about that simple asset management diagram with while you were discussing, and that was up at the start of the slide set here. Yeah. So this was a diagram that I used last year and is still quite topical around the place. And it's around the core of asset management planning, of course, is life cycle management, where you're looking at your operational planning, maintenance, renewals and replacements, new capital, disposal of assets, optimizing all those programs. But the feed into that is what service are you providing, what demand for that service is going on. And I think that was, again, coming back to Flint, one of the problems there, because they've obviously lost economy and population out of Flint from maybe 2 or 3 decades ago, and it was around affordability of infrastructure. It's the hardest scenario to manage is when you've got economy and population moving out of an area, because you've got lots of assets for the previous demand for that, but not so much to pay for it. And then risk, and then you've got that two sides of financials, the expenditure and the revenue. So you can produce a plan that shows that you need to spend lots and lots of money, but somebody's got to pay for it. And so we still find this diagram very helpful in just understanding the whole of that asset management process. What isn't on this diagram, because I've tried to produce it for maximum simplicity, is inventory. It's just assumed that you will have an inventory before you start trying to make all the rest of those decisions. So.
And one final thought before I think Savannah has a poll question for everybody, but one final thought on the inventory piece is, again, sort of tying it back to Flint. When Flint happened, a logical question that started being asked all around the country is, do we have the same problem? You know, is there lead service lines in our system? And many utilities didn't know the answer to that question. So one of the reasons we want to do inventories and understand what our assets are is if we can't answer that question, then we don't know if we have the same kinds of risks. Again, it's sort of that hidden risk. Is there a hidden risk that, you know, if something changed in our water quality, would we have the same problem? Would we have the same issues? And so really understanding your assets, you know, what you have, what condition they're in, where they're located, can help you in so many ways. And it was a very hard question for a lot of utilities to ask or to answer, was, do we have the same potential problem? And many utilities are out there looking right now to see if they have lead service lines anymore.
That's a good thing.
So, you know, hopefully in the future, if we have more inventories, we'll be able to answer the question right away. If something else happens somewhere, we can say, well, we don't have it, or we do. So the more you know about your facilities, it can only help you. So knowing things is never a bad thing. It's always a good thing. It can always help you.
Helps you manage that risk, doesn't it?
Yes.
And deliver a service.
Savannah, did you have some poll questions?
Yes, I do. So before we wrap up, I do have 2 more polling questions for the guests on the call. The first polling question is, if you're a small water system, would you be interested in receiving in-depth technical assistance? If you don't have a chance to submit your question, you can review the technical assistance form on the efcnnetwork.org website. The following question is if you would like to subscribe to the Environmental Finance Center blog. Again, if you didn't have a chance to sign up or submit your answer, you can sign up on our efcnnetwork.org website. And lastly, I will be sending a survey through the chat box. Thank you in advance for your time. Please take this survey and let us know what you thought of today's webinar. I also would like to say thank you to Heather and Ross for the wealth of information and being the experts for today's webinar, and a thank you to Dawn Nall for moderating today's session. Thank you to all the guests on the call for the various questions. Have a wonderful day and enjoy the weekend. Thank you.
Thank you, and happy 4th of July, everybody.